Okay, so I'm going to go ahead and get started. Welcome to this CSE 120 workshop. Today's agenda is going to be terms and literals. We're going to go over SOP and POS and Kmaps. So these are the QR codes for the FSCTC social media. I'll just wait over here for a minute if you guys want to just grab a picture of that so you could get regular updates of our workshops and the tutors' schedules. And this is the link to sign into the workshop. I'm just going to drop it in the chat. Could you guys just sign in and let me know once you're done?
Why would the sign in ask us to rate the workshop if it hasn't even begun?
Okay. So just keep that link on. I'm going to remind you at the end of the workshop too.
Oh, okay.
Okay, cool. Okay. So I'm going to move ahead now. I'll give you this link at the end of the workshop as well. Okay. So I'm Aishwariya Ranjan. I'm a computer systems engineering junior, and I joined the special programs team this fall. So today's learning objectives, like I said before, terms and literals, canonical SOP, POS, and Kernel Maps. So let's get into terms and literals. So if you're given an expression like this, in this, each letter is a literal and each group of letters is a term. So over here you have 7 literals because there are 7 letters, and even if D repeats twice, you're going to count it separately. So there's 7 literals and there are 3 min terms. Min terms because they're being added together over here. So they're min terms. And over here, again, each letter is a literal and each group of letters is a term. So we have 5 literals and 2 max terms. Over here, max terms because these terms are being multiplied together. So they're like logical and together. And the previous one, they were being logical ORed together. So they were min terms. Any questions here?
Could you show me the previous slide one more time?
Sure.
Thank you.
Okay. So now that was something we needed to know to get into the sum of products. So the sum of products is just a Boolean expression where the products of the inputs are being added together. So I'm going to show you some examples too, but it's basically products of inputs being added together. The product of inputs, like I said, is a Boolean logical and the sum or the addition would be the logical OR. So there are 3 kinds of sum of products: canonical SOPs, non-canonical, and the minimal. So canonical sum of products, in this, each term in your expression should contain all the literals involved. And each product term is a min term because they're being added together, it's a min term. Therefore, the canonical sum of products is also called the sum of min terms because each term is a min term. So in this case, if we look at the truth table over here, a canonical sum of products is taken for each term which gives you an output of 1. So over here, X, Y, and Z are inputs, and F is the output. So you're getting out F as 1 for these 4 terms. So you're going to write them down like this. So X is a 0, so that would be X bar. Y is a 0, so that would be Y bar. And Z is a 1, so that would just be Z. And you're going to similarly get out all the terms. and you're going to add them together because it's a sum of products. So, and this is how you find it written in your questions, or how you have to express it. The sigma sign with a small m because it's min terms. So that's how you form the canonical sum of min terms. Any questions? Okay. So for a non-canonical sum of products, you do not need each term to contain all the literals. So I just have this expression from our previous page. So this is a canonical sum of products because each term has each literal. And we can simplify this if we see this highlighted portion. X bar and Y is common in both these terms. So if we factor them out, we're left with Z bar plus Z, which when you add together gives you 1. They cancel out, so it would just give you 1. So you would end up having this expression. So this term doesn't contain all the literals, it doesn't contain Z, but it's still a valid term. It's still a valid expression. So this is the non-canonical sum of products. Now, a minimal sum of products is the most simplified SOP you can get. So it is a non-canonical SOP, but it's different because it's the most simplified. So over here, from the previous page, we saw that we could factor out we could factor out X bar Y from these two terms, but we also see that in the blue terms, we can factor out Y bar Z. So then if we factor out Y bar Z, we are left with X bar plus X. So those cancel out. And in these two terms, we can factor out X bar Y, and the Z bar and the Z cancel out. So you're left with this expression, which cannot be simplified any further. So that's your minimal sum of products. All good here?
Yes, thank you.
Okay. So now we're going to move on to the sum of products. Okay, so the sum of so the product of sums, is a Boolean expression where we take the product of dissimilar sum of inputs. So it's the opposite in a way of the sum of products. Over here, the sum of inputs is a logical OR, and the product of those sums will be a logical AND. Again, there are 3 kinds: canonical, non-canonical, and minimal product of sums. So canonical product of sums, like its SOP counterpart, has all literals in every term. And each term over here is a max term. This time it's being added together, the literals, that's a max term. Therefore, the canonical SOP is also called a product of max terms. So now if you have a truth table and you have to find out the product of sums, you have to take each term which gives you the output as 0. In sum of products, we used to take output as 1, but for POS, we need an output of 0. So you're just gonna get out all those terms. So like for the first one, we have when X is 0, when Y is 0, and when Z is 0, you're getting an output of 0. So you're gonna take those, but instead of multiplying them, you're gonna add them. So X bar plus Y bar plus Z bar gives you this 0 over here. Similarly, you're gonna extract the other terms for which your F or output is 0. And then you multiply them together. You put those terms together in multiplication. And the formal way to write this would be this. So F equals pi capital M, because this is these are max terms. And then in the brackets, you're just going to write the numbers for which you got the output as 0. A non-canonical or minimal product of sums is you're just going to if you have your canonical expression, you want to try to simplify it. So you see in these two terms, y bar and z bar are common again. So if you factor them out, you would be left with x bar and x, which would again cancel out to give you y bar and z bar. Similarly, over here in these blue terms, z bar and z would get canceled out. So you would be left with this, and this cannot be simplified further. So this would be your minimal product of sum, which is also a non-canonical product of sum. Clear? So I have a question for you guys. I'm going to give you 2 minutes. Try to write this as a sum of products. Okay, so keep in mind when you have defined SOP that when you expand these numbers, the zeros in them means it's complemented. That is, like, for example, a bar, and the 1 means it's not complemented. So we hear these numbers in the brackets, if you expand them into 3-bit numbers, because that's what the question specifies, f of a, b, and c. Okay, that's all right. Okay, so you'll expand each of these numbers into 3 bits because f of a, b, and c. So 0, 0, 0 means each bit over here is a complemented bit. So it would be a bar, b bar, c bar. Similarly, you would expand all of these numbers. And for wherever you're getting a 1, that would be an uncomplemented number. So now you see that you just have to add all of these together because it's a sum of products. So these are your products. And to get the final expression, you just have to add them all together. Any questions?
Nope.
Okay. So I'm going to pause over here for 2 minutes as well. Okay, there's a correction on this page. I want you to find the canonical product of sums, not the sum of products. You could find out from here as well, because this is capital M, so we're looking for the max term. So that would be product of sums. I'm giving you 2 minutes. Okay, so now for when you have to find the product of sums, the zeros and ones take an opposite meaning. So 1 over here means complemented, for example, a bar, and 0 means uncomplemented. So if you expand your um, digits over here into 3 bits again, because the question asks for f of a, b, or c, so zeros would be uncomplemented. So you would get a, you would get a b, and you would get a c for these 3 zeros. But since this is asking you for a product of sums, you would add them together instead of writing ABC. So you just expand all of those digits similarly and make sure to add the literals together. And so your final expression, you would just have to take each of these terms and multiply them. Okay, so now we'll move on to Karnaugh maps. Kernel maps are basically an easier way to obtain your minimal SOP or POS. So to solve a Kernel map, to solve an expression using the Kernel map, we build the Kernel map depending on the number of variables in our question. Then we identify the min or max terms. So if the question is asking us for SOP, we would write down the ones. And if it's asking for the max term, we would write down the zeros. For the SOPs, yeah, we just put ones in the blocks of the Kmap. And for POS, we put zeros. And we make groups. We circle those ones or zeros, and we try to make the largest circle, which contains the number of ones or zeros, which is a power of 2. So you could group together 2 ones, you could group together 4 ones, but you cannot group together 3 ones. And yeah, so you would try to find those groups and then try to express those groups, and that would give you your minimal SOP or POS. So let's start off with a 3 variable Kmap example. I'll just give you a chance to do it. I know you guys covered it in class, so if you can. And then I'll show you the answers shortly. So over here, you have to find the SOP. So it's this symbol, the sigma symbol is telling you have to find the SOP of A, B, C. So you have 3 variables, and these are the digits you need to express in your Kmap. Okay, so this is how we would construct the Karnaugh map. We would, I'm going to express A and B on the top and C on the left side over here. So when we write down a Karnaugh map, we label these columns bit by bit. So we start with 0, 0, and then 0, 1. And now over here, instead of going to 2, we write 3 because we want to change 1 bit at a time. So over here, we'll write 3 and then we'll write binary 2. And for C, we would write 0 and 1 like this. So the value of this cell is 0. And as you go down, it's 0, 0, 1. So this is 1. Then 0, 1, 0. So this is 2. This is 3. But since this is not going in order, this is not binary 2, this would actually be 6. So when you number it, it's easy to remember it as this is 0, this is 1, 2, 3. Then you skip over this column, 4, 5, and then come back to it, and that will give you 6 and 7. So now we have to take these numbers in the question and fill it out over here. So we have a 1, so you would fill in the 1 box, then a 3, so you would fill in the 3 box. Similarly, you'd fill in 1s for 6 and 7. Over here, you're filling in 1s because it's asking you for the sum of products. So now we have to group our 1s to the power of 2. So we make this group and we make this group. Keep in mind, we won't make a group like this because that would be grouping 3 ones, and that is not a power of 2. So that would be wrong. So these are the 2 biggest groups we can make. So now we'll express them. This red group is limited. I could the easiest way or the smallest way in which I could express it is by saying it's an A bar C, because A bar it's in the 2 columns where A is a 0. So it doesn't matter what B is. So A bar, and then it's in the row where C is 1. So these 2 ones can be expressed as A bar C. Now these 2 ones, they could be expressed as AB because they're taking the whole of the column where A and B are both 1s. So for the final expression, since it's a sum of products, this will be a product, this will be a product, so you just add them together. Any questions? Okay. Now this is a 4-variable Kmap example. You could see that because the question has 4 variables over here. And again, you want to find the minimum sum of products. So I'll give you 2 minutes for this. Okay. So we have 4 variables. So the top would be A and B, and we would express the rows with C and D. So again, this would be 0, 0, 0, 1. Then we want to change only 1 bit at a time. So this would be 1, 1, 1, 0. You would label C and D similarly. And so the value in each box would go as 0, 1. Then you would skip this 2, 3, 4, 5, skip 6, 7. And then you would skip this entirely. You would fill this up first, 8, 9, 10, 11, 12, 13, 14, and then 15. It's going to seem complicated in the start, but once you start doing a lot of these questions, it's going to get easier, and it will help to just memorize the order instead of sitting and like counting out. So if I want this cell, it would be 1 1 and then 1 1. So that is 15. You could do that, but it's a time consuming process. So now that we have our Kmap, we would we would put ones in all the numbers over here. So we have a 1 and 3, 2, 4, 5, 10, 11, 12, and 13. So once I have all the ones, I want to make the biggest circles I can. So for these 4 ones over here, I can just group them all together. They're a power of 2, so that works. And now for these 2 ones and these 2 ones, I could this map, you could imagine it like wrapping around, so you can group this and this together to make your biggest circle. So then we have 2 groups of 4 ones. So to express the red box, you have to see what limits it. So both of them are in columns where B is 1. So it doesn't matter what the value of A is, they're both in columns where B is 1. And over here, they're both in rows where C is 0. So this red box could be labeled with B, C bar. And for the green group, you would see that both of them are in columns where B is 0. And they're in rows where C is 1. So that is another group you would make. That would be B bar C. Any questions here? All right. Okay, so this is a 3-variable Kmap example again, but over here we are finding the product of sums instead of the sum of products, as you can see from this pie over here. So again, I'm just going to give you 2 minutes to quickly figure this out. And then if you've done it in class, and I'll then go over the answers. Okay, so first we build the Kmap normally. And now, since we're finding the product of sums, instead of putting ones in the numbers over here, we put zeros. So for 0, we put 0. Similarly for, let's pretend that this question was asking you 1 over here. So 0, we put a 0 for the 1 box, and the 6 box, and the 7 box. Now we group them again. The biggest group possible is just 2 of these together. So now we see that this is this can be expressed as A bar, B bar. This takes up this whole column. So we have these two literals to express this green box. And for the red one, we can express it, both A and B are 1 and they take up this whole column. So A and B. But we wouldn't just multiply them together like we did for the SOP. For the POS, we have to do an extra step. We find the literals and now we have to take the complement of them and then we add. So this would be your answer. You would take the complement of A. So that would be A bar would become A, B bar would become B, and then you add them together. And that's one term. Similarly, A would become A bar, B would become B bar. You would add them and that would become another term. And if you write them down together, like you multiply them, then that will give you your final minimal POS. Okay. So now we have a 5 variable Kmap problem. It's long. I'll give you 2 minutes again to do it, and then I'll go over. Okay, so now the Kmap for this you would need a extra literal over here. So A, B, C, D could only express up to 4 variables, but you need one more variable to express numbers after 10. I mean, sorry, after 15. So you would write down 2 Kmaps, and on top of that, this Kmap would be for the terms where E is 0, and this Kmap would be for the terms where E is 1. So now we build the Kmap similarly to the 4. This is just like what you would build for a 4 variable Kmap. You would build 2 of them, and the numbering would be as follows. So 0, 1, 2, 3, 4, 5, 6, 7. You would go all the way to 15. And then the numbering continues on the second Kmap. So 16, 17, 18, 19. You would have to do that kind of skipping to fill this up, and it goes up till 31. So now once you have this down, you could just fill in ones in all the numbers over here. Ones because this is SOP because of the sigma and small m sign. So I filled in all the ones over here and I tried to make the biggest group. So I saw that, let's start with the red box. So I circled these together and I see that on the other Kmap, these ones are also there. So these two could be grouped together as well. So this red box over here and the red one over here, they're part of one group. Similarly, I noticed that I have 2 ones left out over here and left out over here. Suppose I hadn't circled these 2. I could just loop them together like this. I'll annotate for you. I could have done this and this, and then this and this. and then grouped those together, that would have worked, but that is not the biggest group we could make. To make this even bigger, I could circle this and this. So now I have a group of 4 ones. Similarly, it's possible even on this Kmap. That's why I would do that. And then now if I group them together, I have a better expression with with lesser term, with lesser literals. So that's how the green circles came about. And now I see I have a 1 over here and a 1 over here as well. So that could be one group. And then I'm left with these 2 ones over here. They cannot be grouped with anything on this side. So I would just have to make the biggest group I can in this Kmap itself. So once I do that, I will express, I'm ready to make my expression. So this red group over here would be, they're covering this whole column. So this column is expressed by A bar, B bar on both Kmaps, of course. So it doesn't matter what the value of C or D is or what the value of E is, they take up A bar, B bar. So that's what we will express them with. And now for the green group, they are in columns where B is 0, and they're in rows where D is 0. And since they're in both the Kmaps, it doesn't matter what E is. They can be expressed as B bar, D bar, as shown here. And this brown group over here, it's in the column where A is 1, B is 1, A, B, and it's in the row where C is 0, so C bar, and D is 1, D, C bar, D. And since it's in both Kmaps, we don't care what E is, we can just express it as A, B because of the column, and then C bar, D because of the row. And now finally, we have this pink circle. So it can be expressed, it's in the, so it's across all columns, right? So it doesn't matter what column it is. So we'll move on to the rows. It's in this last entire row, which is expressed by C, D bar. C is a 1, D is a 0. So C, D bar, and it's not on this Kmap. So we have to limit it only to this Kmap over here. So this Kmap is denoted by E is equal to 1. So that's why to write this pink group's expression down, it would be C, D bar, and E. And once you have all your terms, you would just add them together. Once you have all your terms, you would just add them together to get your final expression. All clear here? Okay. We'll move on to a 6-variable Kmap. So again, I'm gonna give you a little longer this time to do this Kmap. It's similar to the 5-variable Kmap. It's just that instead of 2, you'll have 4 now because you have one more variable, right? So it would be expressed by A, B, C, D, E, and F. So you would have a Kmap for expressing that extra literal as well. So you would have 4 Kmaps in total. So I'll just give you a little bit of time if you want to try it out yourself, and then we'll go over the answers. Okay. So, like I said, we would need four variables. We would need six variables, so we need four Kmaps. And this time I've labeled it A, B bar. Okay, so the columns are expressed by C and D. The rows are expressed by E and F, and each Kmap is individually expressed by A and B. So this Kmap is the same as the four variable, but this is expressed as A bar, B bar, A bar, B, so 0, 0, 0, 1. Then we go like a circle. And again, we're following this trend where after 0, 1, we go to 1, 1 directly. So that's why 1, 1, and then 1, 0. So we go like this. And again, we number all of these down like how I explained before. You would reach up to 63. So this is like a 64-bit. You could think of it as you're expressing 64 bits. So the question, I couldn't put it on the same page because it was too big, but I basically put ones in everything the question asked for. And then we start grouping. So we see that this whole column is filled by 1. And similarly, this whole column is filled by 1. So we could group them together, right? This is the biggest group. It has 8 ones, which is a power of 2. So we're good. Now, I see that in the other Kmaps, these ones are placed the same way. So we could group them all together, and that will give you this big group. All of the red circles are one group. Now I have a 1 over here, and I see I have a 1 over here as well. So I could group these together. And then I have this left, and it's not expressed in any other Kmap. So I would just have to make a group over here of its own, the biggest group I can. So now I have to write down all of these groups. I see that this is contained in the columns where D is 0. So this whole red thing circle could just be expressed by D bar. And now to express this group of green, we see that this is in the column where C is 0, D is 1. So that is C bar D. And over here, E is 0, F is 1. So E bar F. And it's only in these two Kmaps. So we have to see what is common in these two Kmaps. We see that in both of them, A is 0. So we could just limit them by saying they're in A bar, the Kmaps where A is 0, so A bar. So your total expression would be A bar, C bar D, E bar F. And finally, you want to express this. So that would be, it's contained in this row where E is 1, F is 0. And it's only in this Kmap. So you have this Kmap's identity is expressed by this. So you have A bar B, E, F bar. That's how we express this here. And I also noticed over here a mistake I made on my part. We have to make the biggest group possible. So we could have grouped this together and grouped this together and then linked them. So that would give you a better expression. Hold on. So excuse me. Yeah. So this is in the column where A is 0. So that will give me A bar. And it's in the row where E is 0, F is 1. So that'll be E bar F. Oh, I'm sorry, not A bar. This is in the column where C is 0. Over here, C is 0. So that would be C bar. And now it's only in these two Kmaps. And the common thing in these two Kmaps, once again, is that A is 0. So A bar. So you made this term simpler because you made a bigger group. So this D got canceled out. So you have one lesser term, which does make a difference. So that's how you could find out the minimal SOP of 6-variable Kmap. To find the POS for all these cases, like we discussed in the example before, you would have to put zeros where the question asks you, where the question will have a set of numbers. So you put 0 over there. And then you try to express them like how we did over here with the letters. But instead of multiplying them together, you're going to complement each of them. And then you're going to, you're going to complement each of them. And then you're going to add them together. And then when you write those expressions down together as a group, that will give you the POS. Any questions here? Okay. That's all I had for you guys today. So we discussed terms and literals. Each letter is a literal in a term, and each word we make together with those letters is a term. So we discussed SOP and POS. There are 3 types for each. Canonical, where each term has all the literals expressed, and non-canonical, where you don't have to have all the literals, and minimal, where you just want it to be in the simplest form possible. And then we discussed how to get the minimal SOPs from Kernel Maps from 3-variable, 4-variable, 5, and 6-variable Kmaps. So that's all I have for you today. You could complete.
Question on the previous one. How do you determine which one will be on the outside? Because you did one where, like for that one, it's like A naught, B naught, A naught, and then B. But then on one prior, I believe it was like A naught was inside and being like put like 0001
Oh,
for all those.
inside? Okay, you mean over here, right?
Yeah. How do you determine which one
Okay.
uses the main one versus the other one?
So you could have A, B inside of your C, D, and then E, F outside, but the numbering inside would change. So I kept it this way because I like going from 0, 1, 2, 3. So if you see this, how is this 0? Because this is 0, this is 0, 0. So all of them are 0. That doesn't tell you anything. But if you want your number 1, so that would be 0, 0, 0, 0, and then 1, because it's a 6-bit, right? This 1 should come at the end. So A and B have to be 0, so that would cover these two. Then C and D would have to be 0, that would cover these two. And then E and F would give you 1 over here, right? So this is E and this is F. So if I count all of those, that will give me this box exactly. So that's why I chose to put A and B outside, because this numbering pattern that I was using for the other Kmaps, for my 4-variable Kmap, this is how the numbers were coming out. So I want to keep that. It's okay if you want to put A and B inside over here and C and D outside. I mean C and D over here, and then E and F up here. But then you just have to make sure you have all these boxes numbers correctly.
Could you show me like just on the first one how the numbering pattern would be different? Because I'm kind of confused on that. Because when you number the Kmap boxes, I've had trouble understanding. Like I understand because you move the final box like inwards, up one, how that switch causes it to be like 0, 1, 3, and 2, and then like how that also works on like the other like vertices or like axis.
Okay.
But I would just like to know like how that change would work if you did that instead, like the number.
The change, you mean like if I had A, B inside C, D?
Yeah.
Okay, I see. So if you have A, B over here, C, D, this is Okay, so 0, 0. One, 1, 1, 0. Oops. Okay. And then we would have E and F on the top. So this would be E bar, F bar, 0, 0. So this box would be 0 because all of them are 0. So the value is 0. Now this box would be 0, 0. So you have 0, 0. And A, B, C, D would be 0, 1. And then EF would give you 0, 0. You follow the order. So this box's value is actually 4 now.
Oh, okay. I understand that. I understand that.
See that? Okay. That's how the numbering changes. So it would have a pattern in itself too, but this is what I was used to. If your professor is using some other pattern and that's what you're comfortable with, you could go along with that also.
Oh, I appreciate that. I was just like, I just want to know how you could work backwards to figure out how to create a Kmap. And so the
Right.
numbering decision was something that always confused me. So I appreciate you explaining that.
Okay. Any other questions?
That's all I had.
Okay.
That part of the video. So
Okay, that's great then. So this is essentially the end of the workshop. If you have you signed in? If
yeah,
you could,
I
okay,
signed
that's
in.
great. Okay, then that's it for today. I guess if you have any other questions, I could take them.
I don't have